Hey everybody, it's Mr. Carr again. Today we're going to be talking about 6D, graphing systems of linear inequalities. Okay, so let's first talk about what is a system of an inequality. Okay, this is when we have more than one linear inequality on the same graph. Okay, so you can actually do a whole bunch. You can do 4 or 5 lines, it doesn't matter. But as long as we have more than one linear inequality on the same graph, that creates a system of inequalities. So we look at this. Just like we did before, we did a shaded region for just a single linear inequality. We got one line and we're shading below or shading above the line. Okay. Here, we're going to have more than one line on there. So that means that the solution is the region where the shading overlaps. Okay, it's kind of like when we did our compound inequalities. When we did an and statement, we had this. We had shaded regions going opposite directions, so there's overlapping there. Kind of the same thing happens here. Okay, so we're going to graph the given systems of linear inequalities, and we want to mark our final answer with an R. Remember, an R means it's a specific region. Okay, so let's look at part A here. So just like we put before we did, it's crossing at the point 0, -1, and the slope here is a -3/1. Okay, this one, the second equation needs to be rewritten. So I'm going to subtract x to both sides so that -y is greater than -x minus 3. Divide everything by a -1. And that flips my sign, so it's going to be less than a positive x plus 3. Okay, so this means I'm crossing at 0, 3. And my slope is a 1/1. So I'm going to start with graphing both these lines. Now, recall from before, these are both less than and greater than, so they're both going to be dashed lines. Okay, so I've got 0, -1, and then a slope of up 1, 2, 3 to the left 1, 1, and then I'll go 1, 2, 3 down 1 like this. Okay, so that's the first line. Second line is going to cross at 0, 3. So 1, 2, 3. And the slope of 1/1 is going to look like this. Okay, now the shortcut of this is to make sure is if you understand where things go. So when this one right here is greater than, that means that was this line. Greater than tells me you're going to go up. Okay, that's where that goes. The second equation was a less than. So for this equation here, less than goes down like this. Okay, so as a shortcut, you just have to understand where the shading should go. I don't like doing a full shading in because it gets a little bit tricky, especially on my iPad here, but you could do something like this. So the first case is greater than, so it kind of goes up like this. This is where the shading would go, is upwards. The second one is going to go downward since it's less than. Okay, you notice if you look closely enough, there are 4 sections. 1, 2, 3, and 4. Out of those 4 sections, only one of them has the blue line and green line crossing each other. That's that overlapping region. Okay, we want to find where it overlaps. So that means that is right here. That's my shaded region there that overlaps. That's that section 4, I guess. Okay, so blue and green cross each other. It only happens there. This section is only blue lines. This is only green lines, and this is nothing. Okay, if you're ever not sure, you can still graph it with the shading like we did before. Pick a test value. Pick something that the point does not go across. So for example, 0, 0. Tested in both of these inequalities. Okay, so you would get true for both of them. So if it's true for both, you would shade going this way and then going this way as well. Okay, so that's what we're saying with that one. Make sure you are shading both of those inequalities and then finding the overlapping region. So part B, you're already set up. I've got a dashed line here and then a solid line here. Okay, based on the inequality symbols. Crossing at 0, 1 for the first equation, negative 2/3 for the slope is going to go up 2 to the left 3 or down 2 to the right 3. I'll do one more and one more. Okay, so that was a dashed line. The other equation is going to go positive 2, so I'm crossing right here. And negative 2/3 is actually going to go up 2 to the left 3. This one probably should have been a little more space. 3. Okay, so you can barely see it, but these are actually going to be parallel lines. Okay, so a little frustrating with that one because it's not a lot of space there. So we are looking for where is there a shaded region where it's true for, basically we're looking for true for both. So we are greater than this one, less than this one. It's really tiny, but greater than the dashed line is going to go up. Okay, less than the solid line is going to go down. So the only shaded region that works is this tiny little sliver in between. That's my solution area. Very frustrating with that one because it's so small, but that's the idea. All right. We did the same thing here. Okay, so there's a little bit more space here at least. So we look at these ones. We're crossing out 0, 2, and then 0, negative 2. And they both have a slope of negative 3. So it's going to go 1, 2, 3, 1, 1, 2, 3, 1, 1, 1. And same thing here. Okay. Yep, nope. There's skinny region here. Okay, so the positive 2 is a greater than or equal to, so that gets a solid line. And then the less than is a dashed line. Okay. In this case, you got to be very careful because when I graph the solid line, that is greater than, so that's going to go up. And then the other one is less than the negative 3x minus 2, which is going down. Remember, we said that the shaded region that overlaps is my solution, so on. I have no overlapping here. If there's no overlapping, no solution. Okay, no overlapping regions. Okay, so I can have it with the parallel lines like this, where it's that tiny little sliver in between. That's my solution area. Here, it goes the opposite directions. Okay, that doesn't work. There's no solution there. Okay, so I can have no solution with these types of things. It's a little bit tricky, but that's what happens here. All right, and that is it. That's all we do for our systems of equations, systems of linear inequalities. You're going to graph both inequalities on the same graph. And you're going to find the overlapping shaded region, and you can just kind of treat both inequalities separately. Okay, figure out which way to shade based on one of them, if it goes up or down. And then the same thing with the other line, it goes up or down, and you see where do the two shadings cross. Sometimes we actually have no crossing because of parallel lines, and that's okay. That just means no solution then. All right, that's it for 6D. All right, if you have any questions, feel free to reach out. Otherwise, take care, everybody.